Okay, we're going to look at the end behavior of a polynomial. So we've graphed a couple of things like the parabola. So you could have a parabola opening up, parabola opening down. Then we also did the cube function, and maybe a reflection of it. And so you see where all these arrows are pointing. That's your end behavior. So we want to know where is it going to. Now for the x squared, you either were opening up or opening down, and that depended on if you had a plus or minus in front of you. And then the x cubed, for instance, the end behavior depended on if you had a plus or a minus. And so we're going to generalize that to polynomials that are a little bit larger than second degree and third degree. So if we have a generic polynomial, f of x equals a x to the n plus blah blah blah, a naught, which is the constant, what we're going to focus on is the highest exponent, the x to the n. That's going to have the most weight. So when we're talking about end behavior, we're talking about large numbers. So if I square a large number, it's bigger than the original large number. If I raise a large number to the fifth power, that's larger than that large number to the second power. So the nth power is going to determine what it's going to do. It's called boss or something if you want to say something silly like that. So if n is even, think of the parabola. The parabola either opens up or it opens down. And it depends on what a is. If a is positive, we say it starts high and ends high. And so it's gonna have, kind of like the parabola, the two branches are going up. If a is less than 0, we say it starts low, starts at negative infinity, low, and at infinity it's low again at negative infinity. Okay. Then if n is odd, think of the cubic function. So it starts low, ends high, and then if we have a negative in front of it, it's going to reflect it, so it would start high and end low. So if a is greater than 0, starts low and ends high. So starts low, ends high. A less than 0, just a reflection, starts high, ends low. Okay. So we're only focusing on, is the highest degree, is it even or odd, and then is the leading coefficient positive or negative. That's all we're paying attention to. Okay. All right, and then some notation. If we say x goes to infinity, that means we're going to the right, or x goes to infinity. And then similarly, we have one for x goes to negative infinity. That means we're going to the left, or negative infinity. And then stuff is going to happen with the y's. The y is either going to go to infinity, or y might go to negative infinity. It just depends on the degree, and it depends on what a is. So that little arrow there just means goes to, or approaches. It's just math efficient notation, because we don't want to write goes to infinity, goes to negative infinity every time. We're trying to be efficient. Maybe lazy too, but definitely efficient. Okay. So starts low, ends high, just as an example. So as x goes to negative infinity, that's going to the left. As x goes to negative infinity, the y is going down to negative infinity also. So the y is going to negative infinity. As x goes to infinity, the y is going to infinity for this particular example. All right. What if we have starts high, ends high? Okay, so that's what it looks like. So as x goes to negative infinity, the y is getting very big and positive, so y is going to be approaching positive infinity. And as x approaches positive infinity, the y is also going to positive infinity. Okay, So this notation, along with the arrows there, we're looking for this notation in terms of your communication of what's going on. But you know, these little arrows right here can kind of help you figure things out. Okay, so let's describe the end behavior here. So f of x is equal to 2x squared minus 5. So the first thing I'm going to look at is the leading coefficient is 2, which is positive, and then this is a second degree polynomial, and that is even. So even means either both go up or both go down. Because the a is 2, which is positive, it's opening up. So it's like a field goal. So as x goes to plus or minus infinity, the y is going up in either direction. So if I go to negative infinity or positive infinity, the y is going up both times. Okay. So look at another one. F of x is equal to negative 2x to the 7th plus 3x squared plus 12. Okay. So I'm looking at the leading coefficient, which is a negative 2, so the a is negative, which is our reflection. This is an x to the 7th. Odd functions normally start low and end high, but it's a reflection, so it's going to start high and end low. So this is odd. A is negative 2. I'm going to start high and low. So as x goes to negative infinity, so as I go to negative infinity, the y is going up. And then as x goes to positive infinity, y is going to negative infinity. Okay. Alright, so let's look at, I think we got one or two more. F of x equals negative x squared times x squared plus 7 raised to the 4th power. Okay. So the degree of this one is going to be the x cubed, which is a 3, plus, if I expand this all out, I'm going to have an x squared plus 7 times itself 4 times. So you'd have x squared times itself 4 times. So that'd be x to the 8th, or 2 times 4. So the degree of this is 11. It's odd, so that's either start low, end high, or start high, end low. Because it's negative, it's the start high, end low. Okay, and as x goes to negative infinity, the y goes up. As x goes positive infinity, the y goes down.